All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. Today, I want to show you the half angle formula for the tangent. I want to show you how to derive it. But before I do that, I want to show you why that you would need such a thing and how it comes about. A few years ago, I was working on a computer program where I calculated the orbits of planets. And at one point, I needed to say if we were given in the plane coordinates of a planet at points x, y, I needed to figure out what the angle phi from the positive x-axis to the radius of the orbit was. Now, what you might think is that you just use the fact that the tan of this angle phi is equal to y over x, and just use that phi is equal to tan inverse of y over x. And I mean, because that's what tan inverse does, isn't it? But here, it's where we get into the details that it's a problem, because the tan inverse takes in any real number, but it only spits out numbers between negative pi over negative pi over 2 and positive pi over 2. To get the other things, you have to choose different branches of tan inverse. And so here, the angle of this is clearly not between negative pi over 2 and pi over 2. And so it's at this point we need to learn to get a little tricky. So what we can do at this point is to bring out another formula, and the formula is for tan of phi over 2 is equal to the sine of phi over 1 plus cosine of phi. And if we do this, well, what we can make a little hay out of it. We note that the sine of phi is equal to y over r, and the cosine of phi is equal to x over r, where r is equal to the square root of x squared plus y squared. We can then say that the tan of phi over 2 is equal to y over r over 1 plus x over r. Then multiply numerator and denominator by r and get y over r plus x. Okay. And so that's the tan of phi over 2 is equal to this, and so therefore that phi over 2 is equal to tan inverse of y over r plus x, and that phi is then equal to 2 times tan inverse of y over r plus x. And so this gives us something where a tan inverse is still spitting out values between negative pi over 2 and positive pi over 2. 2 times tan inverse spits out values between negative pi and pi, leaving out only the angle where these two overlap with each other. Okay, so it leaves out only the negative x-axis. Okay, where it is undefined, and we'll just have to deal with that when it comes up in practice. But it gives us a nice formula. Now this rolls back to, okay, how do we get this formula here? And that'll require a little bit of work on our part. Okay, we want to start off with some basic formulas. And the first of these formulas we calculated in a different video, that the cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a times the sine of b. Now, by replacing b by negative b, I can get from this that the cosine of a minus b is equal to cosine of a, okay, cosine of b, because cosine of negative b is equal to b, minus sine of a, and this would be sine of negative b is negative sine of b, so this becomes a plus sine of b. Okay, so just by that substitution. Now, if I in the first one substitute, say that a is equal to b is equal to theta, then I can get that the cosine of 2 times theta is equal to cosine squared theta minus sine squared theta. And when we start using Greek letters, you know we're serious. Now, if I make the same substitution in the second one, cosine of theta minus theta, that's cosine of 0. Cosine of 0 is equal to 1. And then that would be equal cosine squared theta plus sine squared theta. Okay, so which you may recognize from getting a different way. So we now have some formulas here that are pretty solid. We're going to take those and get some ones that are not quite so basic. Alright, I have a new page here, and on this new page I've carried over my main results from the other side. And what I'm going to do is say, okay, notice that I can rewrite cosine squared as equal to 1 minus sine squared theta, and I can rewrite sine squared theta as 1 minus cosine squared theta. Let's do the cosine squared first. If I put cosine of 2 theta, replacing my cosine squared theta with a 1 minus sine squared theta, and minus sine squared theta again, and I simplify this, I will get that this is equal to 1 minus 2 sine squared theta. Okay, so cosine 2 theta equal 1 minus sine 2 theta. If I do this replacing the sine squared with a 1 minus cosine squared, I get cosine squared theta minus 1 minus cosine squared theta, which will give me 2 cosine squared theta minus 1. Okay. All right, now the first one, I'm going to take this right here, and I'm going to solve it for sine squared. I'll do 2 sine squared theta is equal to 1 minus cosine 2 theta, and then divide both sides by 2. I get sine squared theta is equal to 1 minus cosine 2 theta divided by 2. I can do this something quite similar with my my formula here, and doing so I will get that cosine squared theta is equal to 1 plus cosine 2 theta over 2. Okay. And so if I want to think about I talk about the double angle formulas. Well, we have this right here, the double angle for cosine. If I do want to talk about the half angle formulas, I can show you I mean business again by letting theta be equal to phi over 2, and this will give me that sine squared of phi over 2 is equal to 1 minus cosine phi divided by 2, and that cosine squared of phi over 2 is equal to 1 plus cosine of phi divided by 2. Okay, so half angle formulas. Okay. That's still not the point of my video, which I will get to on the next round. Okay, it's time to roll some of these results together and get our payoff. We start off with the cosine squared of theta is equal to 1 plus cosine 2 theta over 2, and that sine squared of theta is equal to 1 minus cosine 2 theta over 2. And so I'm going to use this to calculate what tan squared theta is. Tan squared theta, that's just tan squared theta is equal to sine squared theta over cosine squared theta. This will be 1 minus cosine 2 theta over 2 times 2 times over 1 plus cosine 2 theta, which will be 1 minus cosine 2 theta over 1 plus cosine 2 theta. Now we multiply this by a well-chosen 1, and that well-chosen 1 is 1 plus cosine squared theta, 1 over 1 plus cosine, not cosine squared, cosine 2 theta. And that's nasty looking. My handwriting is degenerating. Clearly I have some sort of degenerative disease. But anyway, the reason this is well chosen is in the numerator it gives me the difference of two squares. 1 minus cosine squared 2 theta. In the denominator it's just a square, 1 plus cosine 2 theta quantity squared. And so I have here, okay, that tan squared of theta is equal to, okay, 1 minus cosine squared of 2 theta, that will be sine squared of 2 theta over 1 plus cosine 2 theta quantity squared. Okay, now to get what tan of theta is, I take the square root of both sides. That'll give me that tan theta is plus or minus sine of 2 theta over 1 plus cosine of 2 theta. And as so often the case, we have, okay, plus or minus, but which is it? Plus or minus? Well, let's do a thought experiment here. Let's creep in on theta at theta equals 0 from above. The denominator is always positive, but when I creep on sine from above, that'll be positive, and when I creep in on tan from above, that'll be positive. So I need to take the positive branch here, and so I just say take that tan of theta is then just sine of 2 theta over 1 plus cosine of 2 theta. And now we simply replace 2 theta by phi, and in doing that we'll get our formula that we're after, that tan of phi over 2 is equal to sine of phi over 1 plus cosine of phi. And you can take that and you can put it in the bank, and you understand where it came from now. Yeah, who is it? No, I'm not doing anything. Come on in.